speaking of being at the forefront of this LLM movement, I've got Shreya here. Let's see if I can grab her and bring her onto the stage. Yes. What's up, Shreya?
Hey, Demetrios. Nice to see you again.
Yeah, you too. So we just confirmed, right? We're going to see each other in San Francisco when I'm there in 2 weeks.
Yeah, that's right. Yeah.
Yep. So I'm gonna drop by your office, maybe even with Diego, and we can record one of these podcasts that I'm talking about.
Yeah, I think that sounds amazing. We'll have to get an office in time for that, but outside of that, sounds amazing.
There you go. That's living in the hybrid world. Yeah. So no, I'll go by it, but I'll let you go because, as I said before, you can call me Ringo today. I am keeping time, and we're already 4 minutes over. So I'm just gonna give it over to you and hear what you got to say.
Awesome. Thank you. So I'm sharing my screen and that's up here. Perfect. So I'm going to get started. Hey, everyone. My name is Shreya. I am the founder of Guardrails AI, a company focused on building AI safety and reliability for large language model applications. And today I am going to be talking about how to build practical guardrails if you're working in industry or if you're putting LLMs into production. So with that, let's get started. So why do we need guardrails off the bat? LLMs are awesome, but they are brittle and hard to control. And as we work with them, I am guessing a lot of people in the audience have worked with them as well. It's typically a number of issues pop up in practice. So for example, the LLM application works while prototyping, but the moment you run it into production, it ends up being flaky. There's issues with hallucinations and falsehoods, often issues with lack of correct output structure, etc. Interestingly, the only tool available to developers is the prompt. So if you want the LLM to behave a certain way, typically people would just put into the prompt, do not respond with this word or always respond in this manner, etc., which just seems, prehistoric in some ways and insufficient. So all of these issues combined mean that anytime you want to deploy LLMs in an application where correctness is critical, that becomes really hard. And we've kind of seen that in the applications that we see in practice. So what are the tools available to us to control LLMs to start out with? So first is controlling the LLMs with a prompt, but we talked about why this is insufficient, primarily because LLMs are stochastic. And what that means is even for the same input, you might not see the same output repeatedly. So the prompt, just does not guarantee correctness. The second way of controlling LLMs is via the model. But often it ends up being very expensive or time consuming to train or fine tune a model on custom data. And if you're using the LLM, behind an API, there's, no control over model version, et cetera. And the LLM provider might change the LLM from, without notifying you. So the guardrails approach to controlling LLMs and offering guarantees is combining an LLM with output verification. So what that means in practice, and I'm going to dig deeper into this in a second, is that there are application-specific checks and verification programs. So these are small programs that you can run on the outputs of the LLMs that ensure that the LLM output is correct within the context of your application. So that was a mouthful. We're going to dig deeper into what that means in practice right over here. So this is the standard way of LLM development, wherein there's some application logic that lives somewhere, and within that application logic is the LLM unit, which essentially takes the prompt, sends that prompt over to an LLM API, generates the output, and then forwards it out back to the application. The alternative way of doing LLM development that we believe in is that after you get the raw output from an LLM, you pass it to a verification suite. And this suite contains, these small independent programs that we talked about earlier that encapsulate what correctness means, for your application. So this might be, a totally varied set of criteria. So for example, not containing personally identifying information or not containing profanity might be two separate checks. If you're building a commercial application, then making sure that there's no mention of competitors may be important to you. If you're working in code generation, then making sure that the code that is generated by an LLM is executable. If you're generating summaries, making sure that the summaries are correct and faithful to the source text, all of that ends up becoming important. So we get this LLM output and we pass it through a suite of verifications. If all of the verification tests like pass, then we continue on with that output and like send it back to the application logic. But if verification fails, then there's a number of different ways to handle it. And then one of the ways to handle it essentially is to construct a new prompt. So this prompt contains context about what went wrong, and then re-asking the large language model to correct itself and try to produce something that is more aligned with the application's context. So this is where Guardrails AI comes in. So Guardrails AI is a fully open source library that offers a bunch of functionality. So for starters, it is a framework for creating any custom validator. So any of these tests that we talked about, there's nice hooks in the framework to make creating that very easy. It is the orchestration of the prompting to verification to reprompting logic that we saw earlier. Additionally, it is a library of many commonly used validators across multiple use cases implemented for you. And it contains a specification language for how to talk to and communicate with large language models. I'm going to go through this example quickly and make sure I can squeeze it within the time slot that I have. But here we're going to go through this example of getting correct SQL. So the problem is we're building an application that takes natural language questions over your data and generates SQL queries that represent those natural language questions. And for this specific application, our database is like department management that contains information about employees, etc. So this is the same, Guardrails development workflow from earlier. And then within this workflow, our verification logic has now changed where it contains these three tests. So the first is that the SQL query is executable in the code base. So what that means is, once we generate the SQL, we, pass it through our code base, through our database to make sure that the SQL query can actually work. The second verification logic is that there are no private tables that I don't want to expose to my end user. Like none of those private tables are, part of the query. And then the third one is that there are no risky predicates. So even if my end user says like, hey, delete these, drop these tables, etc., those tables won't be dropped or those queries, won't be executed. So let's say that this is the this is the question that we end up receiving from the user: which department has the most employees? So Guardrails, automatically, Guardrails text to SQL package has a prompt that is automatically constructed for this natural language query, which will pass in all information about the schema of the table, other information that may be relevant for answering this query, and sends the prompt over to the large language model. Let's say for this example that this is the output that we end up getting from the LLM, which is, select name from departments. And here, let's say that the departments table doesn't actually exist in our schema. So when we run this output through verification, we find that 2 of our verification tests pass. No private tables or no risky predicates exist in the query that is generated. But because the departments table doesn't exist in the database, this SQL code is not actually executable. So we now enter this validation failure and reconstructing prompt part of the Guardrails workflow, where a re-asking prompt is automatically constructed by Guardrails with all relevant context about why this particular generated query is incorrect. So all of this is automatically done and then sent over to the LLM, and we end up getting this corrected response with the correct table name. We pass this through verification again, so we're back in this part of the logic, and then all verification tests pass, and so we end up passing this output back to our end user. So this was obviously a very, very simple and contrived example, but it goes through the workflow of what building an LLM application with Guardrails AI looks like. So very briefly, I'm just going to leave this up here, not really talk through it, but these are some of the examples of the validators, either available in the library or that you can build with the library, and so they span a ton of use cases. And we only talked about re-asking as a way to handle validation failures, but Guardrails comes with a bunch of other options, including filtering or refraining, raising an exception, just logging incorrect failures if they occur, or trying to programmatically fix them wherever possible. So in summary, Guardrails AI, fully open source library that offers a lot of functionality to make AI applications more reliable in practice, including a framework for creating custom validators, the orchestration of the prompting, verification, and reprompting, a bunch of commonly implemented and used validators available in the library, as well as a specification language for communicating with LLMs. To follow along, you can look at the GitHub package on Shreya r/guardrails. The docs are at Get Guardrails AI, or you can follow me on Twitter or the Guardrails AI account on Twitter, where I continuously show the guardrails philosophy. Yeah, that's it.
Oh, so good. So many great. Oh, sorry, wrong button. I want you to stay on for a minute and the
Yeah, you
slides.
don't need my face anymore. You just need like how to follow along with this.
All right, get out of here. I gotta keep it moving. No, I wanted to show you this. I think you've seen it before, but anytime that I think about this shirt, I always think like, oh, this should be the Guardrails mascot shirt or something,
Yeah.
because it just plays into these LLMs so much. We all know it's true. They hallucinate like crazy, and there are some incredible questions that are coming through the chat. So I'm going to direct you, Shreya, over there. In case anybody wants the I Hallucinate More Than ChatGPT shirt, you can scan this right now and get it. And I look forward to meeting you in person in a few weeks, Shreya.
Likewise. Thanks again for inviting me to be curious.
Yeah, we'll see you soon.